Good evening everyone. Today we are going to see a very small interesting part of organic chemistry. First of all, I would like to draw your attention about organic chemistry. Whenever we think of organic chemistry, we feel like there will be a lot of reactions, there will be very long reaction mechanisms, etc., etc. But I would like to draw your attention into the fact that like any other topic in physics, maths or in chemistry also, organic chemistry is also built up with small fundamentals. So out of those fundamentals, today we are going to see a very small topic which directly or indirectly helps in solving organic problems. So today we are going to see what are sigma and pi bonds. So basically from the definition we can say that whenever two orbitals overlap in end-to-end fashion, like we have shown in this diagram, if there is an end-to-end overlap between two orbitals, then we can say that these two orbitals will make sigma bond. Say for example, here I have taken the p orbital. You can see that the dumbbell shape is of p orbital. Similarly, in the second case, you can see that the two p orbitals, they are overlapping sidewise. Like I have shown here the overlap portion. When two orbitals overlap sidewise, then they form pi bond. So from the very basic common sense, we can say that whenever there is an end-to-end overlap, whenever we shake our hand, so there is a very strong bond that is formed. But if we touch two objects sidewise, or if two bonds overlap sidewise, then the overlapping will be very weak and it can be easily broken. That's why we have written here that sigma bonds are stronger than pi bonds. What do you mean by stronger? It means that during a reaction, it is very difficult to break a sigma bond. But if we apply some catalyst or if we apply some heat, then the pi bond can be easily broken. That is meant by this line. So this left hand side part is what the book's definition is all about. But what about our practical thing? Whenever the questions will come in the examination, at that time we are not going to see a p orbital or s orbital. So at that time we are going to see the compound in this way. In our question paper, the compound will be given in this way. So here we cannot see whether it is a dumbbell shape or whether it is a round shape, etc. So for that we have a very simple trick to understand which one is pi bond and which one is sigma bond. The most important trick is that pi bond is the main bond that connects two elements. Suppose if we take the example of this compound, this is an ethyne molecule. It is an organic compound. There are triple bond, that's why it is an alkyne, it's an ethyne molecule. So here, if we go on marking between this hydrogen and carbon, this is the main bond that I have taken. Then between this carbon and hydrogen, this is the main bond. Now let us come to the main part, which is between carbon and carbon. So between carbon and carbon, if we delete one bond, then also the overall compound remains intact. It doesn't get broken. Then once again, if we remove one more bond, then also we can see that the overall compound remains intact. But now if we delete one more bond, then the entire compound is broken into two parts. That's why we can say that this is the main bond which connects the carbon and carbon element, and that's why this is the sigma bond. Then the remaining other two bonds, this one and this one, the remaining other two bonds can be said as associated bonds. Associated bond means they help in forming the compound, but even without these bonds, the carbon-carbon element can exist. So the associated bonds are called pi bonds and the main bonds are called sigma bonds. So say for in this compound, the number of sigma bonds is 1, 2, 3. The number of sigma bonds is 3, and for this compound, the number of pi bonds, which I have said that associated bonds, are 1, 2. So similarly, let us take one more example. If we see one or two examples, then it will be more clarified. If we see this example, once again, this carbon and hydrogen is attached with only one permanent bond. So these are all sigma bonds. I am giving tick mark in the sigma bond. And let us come to the carbon-carbon element. Here we can see that there is one main bond where we have given the tick mark, and the remaining bond is nothing but the associated bond. So we can say that this is the pi bond. So in this case, the number of sigma bond remains 1, 2, 3, 4 and 5, and the number of pi bond in this case remains 1. So after understanding very simple problems and knowing how to find out the number of sigma and pi bonds, let us see a slightly complicated problem where we will take a ring compound. I hope all of you can identify this compound. This is a very famous compound which is called benzene. I hope we all are familiar with that. So in this compound, if someone asks you to find out the number of sigma bond and pi bond, so what we need to do is, first of all, you try to open the entire structure. Now you might be thinking how we are going to open the entire structure. So just let us see how we are going to open the structure. So this compound, all these corners actually represent a carbon, single carbon. So I am going to put carbon, 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 carbon and carbon. Then I am going to put the double bonds. I am going to put the double bonds. Now if you can carefully see that all these carbon elements have 3 bonds that they are attached with the other elements. So but we know that a carbon element has a valency 4. That means it can form 4 covalent bonds. That means all these carbon elements are unsatisfied. So how we are going to satisfy them? We are going to satisfy them by adding hydrogen. So 1 hydrogen we are going to add here. 1 hydrogen we are going to add here. And now you can see that the entire benzene ring is formed. So this compound and this compound are same. This is called a bond line structure. This is called an open structure. Now when we open the structure, you can go to the previous concept. We have said that the main bond that is connected to 2 elements like this way is called the sigma bond. Remaining all other bonds are pi. So let us count the sigma bonds. Here the carbon hydrogen bonds are all sigma. So this is a sigma, this is a sigma, 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 this is a sigma, this is a sigma. Now let us come to the carbon-carbon bonds. Here the carbon-carbon bond is associated with these 6 sigma bonds, and then the double bonds that are formed are nothing but associated bond. Basically double bond and triple bonds are associated bonds. So we can say that these 3 are pi bonds. So in this entire compound, if we count the number of sigma and pi bonds, then we can see that the number of sigma bond is, just carefully we will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The number of sigma bonds is 12. And the number of pi bonds that can be easily seen, that is 1, 2 and 3. 3 associated bonds are there. So this is the number of pi bonds. So now you might be thinking why we are so much interested in sigma and pi bond. So after knowing the concept of sigma and pi bond, and after knowing how to find out the number of sigma and pi bond, let us go to the application, because without application I don't think any of the topic has got some relevance. Each and every topic which is there in your book has got some application. So let us see what kind of application is there. So I will show you a very simple application of sigma and pi bond. Today I am not going to take a lengthy class. I will just show you a very simple example. So we all know about hybridization. I am sure everyone who has studied chemistry knows about hybridization, and everyone knows how important hybridization is. So in case of organic chemistry, if we talk about the important elements, then carbon becomes one of the most important element in organic chemistry. In one word, we can say that carbon is the godfather actually. So let us see how we can find out the hybridization of carbon atom in different compounds. So whenever we talk about carbon, a carbon element has got 4 valence electrons. We all know. So if it has got 4 valence electrons, then it can form 4 maximum bonds. It can form 4 bonds. Maximum it can form 4 bonds, not more than that. So in different elements, there will be carbon, different compounds, there will be carbon where you will see 2 bonds, where you will see 3 bonds, and maximum you will see 4 bonds, not more than that. So how this and hybridization is related? So in case of carbon element, what we can say that the number of sigma bonds, decides the type of hybridization. So what does it mean? That means in any compound where carbon is there, we can directly say the hybridization of the element. How? By knowing the number of sigma bonds. Previously we have seen how we have to find out the number of sigma bonds, and now we are going to apply the concept here. So I will write a random compound here. Let us see. So basically, if there are 4 sigma bonds, like I said, a carbon element can form maximum 4 bonds, not more than that. If all the 4 bonds are attached directly to an element and all the 4 are sigma bond, then the hybridization of the element is sp3. sp3. There are 4 bonds. Similarly, if there are 3 sigma bonds, then the type of hybridization will be sp2. sp and p, sp2. Lastly, if there are 2 sigma bonds, then the type of hybridization will be sp. It is very simple, but it is a very effective question. You can go back to the previous year questions of NEET or JEE. You can see that many times it has been asked that there is a compound given and you need to find out the hybridization of different carbons. So let us see. I will write a random compound. So let us start with this. So CH, which is nothing but CH3, bond C, double bond C, bond C, triple bond CH. So this carbon has got 3 bonds, so we are going to give 1 more hydrogen. This carbon has got 3 bonds, we are going to give 1 more hydrogen. This carbon is satisfied, this carbon is satisfied. Now everyone is satisfied. So this is an organic compound. Now let us not worry about the name of the compound, that's a different topic. IUPAC is a totally different topic. Now we can see that this is an organic compound which is made of carbon and hydrogen. And the question says that find out the hybridization of each and every carbon. Suppose if I give numbering, then this is C1, this is C2, this is C3, this is C4 and this is C5. There are 5 carbons. So what we are going to do is one by one we are going to check the number of sigma bonds that are attached to the carbon. So let us come to C1. In C1 you can see that each and every bond are directly attached to an element. You cannot break them. So they are main bonds. So we can say that this is sigma, sigma, sigma and sigma. So this carbon is attached to 4 sigma bonds basically if we see. Then let us come to this carbon C2. We can see that this is a sigma bond attached to C2. Once again this is a sigma bond. Then out of these 2 bonds, one is a sigma bond, the other is an associated bond, that means pi bond. One is a sigma bond, the other is a pi bond. So this carbon is attached to 3 sigma bond. Similarly, this carbon is attached to 3 sigma bond. Similarly, now let us come to C4. For C4, this is a sigma bond. Then out of these 3 bonds, one is a sigma bond, the others are associated bonds, that is pi and pi. Here we only need the number of sigma bonds. So in this case the number of sigma bonds is 2 sigma bond. And similarly for the last case, here you have 1 sigma and 2 sigma. For the last case also you have 2 sigma bond. So now you might be thinking that the question was about hybridization, but we are worried about sigma bond. So we can relate this to with these 3 lines. Now if there are 4 sigma bonds, then you can directly say, without even calculating, without even knowing, you can directly say that this is a sp3 hybridized carbon. If there are 3 sigma bonds, you can directly say that this is a sp2 hybridized carbon. Similarly, this is an sp2 hybridized carbon. Lastly, you can say C4, it has got 2 sigma bonds. If there are 2 sigma bonds, then this is an sp hybridized carbon. And then if there are 2, it is an sp. So you can see that in a single shot, without even doing much rough work, we can say the hybridization of each and every carbon correctly. How? By the help of sigma and pi bonds. So this is one example. There are a lot of other examples that we can give, but in my short video I would just like to draw the attention of students that how the fundamentals are very much essential for each and every topic, and also in our organic chemistry these small fundamentals will help you build a better conceptual curriculum for your organic chemistry. Thank you.